Welcome to Co-17C. In case you didn't know what this order was, I feel like most of you know where you're at. Who wasn't in Co-17B with me last quarter? A couple of you. Okay, if you are, cool. No worries at all. Just want to try to describe the ins and outs of the class. It's pretty straightforward. We'll go over the syllabus briefly, but the thing you actually need to know is if you're enrolled in the class for a unit, meaning if you signed up via Schedule Builder with the CRN, then you need to come in person. That's kind of it. Like if you want to pass, if you want to get the 1 unit of workload credit, it's also not a huge deal if you end up not passing this class. It doesn't really affect your GPA at all. I think it shows up in your transcript, but like no one's looking at your transcripts. Nobody cares. But that's it. If you want to pass the class and get the 1 unit, just come and fill out the attendance form, which is making its way around. What else? Let's go ahead and look at Canvas real quick. You all had class earlier today. Hopefully you all went and talked about functions of 2 variables or 3 variables, and probably just 2, and domain, and maybe a couple other things. Let's go ahead and look at our Canvas though. So let me pull this up over here. Let's go to Co-17C, which is this one right there. Oh, actually, wait, one more thing. This is something I can show everybody, just in case you didn't know. You can modify what it says right here in your Canvas if you want to. So you can click the little dots there and then change the nickname if you want to be, I like to write the class time and place often. Right, as you see, mine shows Monday, Wednesday, Friday, 1 to 2 in 1116 Hart Hall or Hart. And you can also change the color if you want a different color. So just so you know. Also, for those of you on Zoom, please do fill out the virtual attendance form, which I have put in the chat a few times. If you have any questions, you're welcome to write them in the chat or unmute yourself and say words out loud. I just might jump a little, but that's all right. Let's see here. So we're looking at Canvas. That's not the right one. I clicked on the wrong one. Let's go to the right one. There we go. So we will try to get through this as quickly as possible because it's really not that important, but it's a little important. So I will try to read, I'll give a summary of what's on this syllabus here, and you can stop me if you have any questions. I'll try to be brief so we can start talking about what we really want to talk about, which is math, obviously. So class, we meet here at this time. You're all here at this time. Great. You are encouraged to come to class in person. So for those of you on Zoom, I'd love to see you in person in class if you can come to class, but I understand if you can't. For those of you enrolled, as I said just a minute ago, for those of you enrolled for a unit, you must come to class if you want to pass the class. For those of you that were in class last quarter, we're not doing reflections this quarter. We're just doing attendance. So I like the reflections in fall quarter to get to know people, but by winter, I feel like I know most people. So if you want to get to know me better, come to office hours. But yeah, just attendance. So make sure you come in person. As far as reaching me, email is best. You can call my office phone if you want, but who calls phones to talk to people anymore? You can also come by my office, or you can find me in office hours, which are listed here. They're also listed in the modules. Real quick, let's look at the office hours just so you know when and where to find me. So you can find me in Math Drop-In, which is in the library, Mondays and Wednesdays from 11 to noon. That's starting a week from today. So next Monday is when office hours and drop-in start, when drop-in starts in general. So there's no tutoring and drop-in this week. And then you can also find me in Centro, Mondays, Wednesdays, and Fridays from 2 to 4. That's starting on Wednesday of this week. And in CADS, which is the Center for African Diaspora Student Success, is starting Wednesday. Oh, that's starting. I feel like that date is wrong there. I should change that. Let me fix that right now. That's starting also on the 8th, I believe, not Wednesday the 13th, because that's not the day that is accurate this quarter. I need to fix that in my other ones as well. Cool. It's good to look through things, right? Make sure they're all right. Back to the syllabus here. Grading. So again, this grading information only matters if you registered for the class. The reason I say this so much is because every quarter, lots of students ask me, like, James, I see like I'm not passing the class on campus. I'm like, are you enrolled in the class? No. Oh, then you don't need to worry about it. So if you're not enrolled in the class, actually, you don't need to worry about any grade things you see in campus because you won't be getting a grade for the class. But if you are enrolled and you want to pass, then you need to come. The passing grade is 70%, which means you have to attend 20 of the classes that meet. That's the math, right? 20 out of, I don't remember how many days this class meets. I think it meets like 28 days this quarter because there's 10 weeks times 3 minus a day off for Martin Luther King and a day off for President's Day. So that's 28 days. And 20 out of 28 is just a little over 70%. Let's see, what else have we got here? If you're enrolled in the class, you're required to attend class in person. So coming via Zoom, while it's great, and I do want you to fill out the attendance form when you come via Zoom, does not count for meeting the attendance requirement of this course. So if you can't come to class in person and you're enrolled in the class, we should talk because we might need to change things, which is fine. Like, you can drop the class and then get re-added to Canvas. It's totally fine. You're same exact access information, everything. So do what works best for you. Let's see, what else? It's hard to read this. The type is small here. If you're not enrolled in the class, you might have filled out the Google form, et cetera, et cetera. You can come any way you like. You can come in person, which is the best. You can come on Zoom during class, which people, let's see how many people are on Zoom right now. Hello to the Zoom people. There are 3 of you. Cool. Hi. I'm not sure how to say your name. Jade twice, and Alicia, I don't know. Welcome, people. Let's see what else we got here. So if you do attend, not in person, I would appreciate everybody filling out this form because we do try to keep track of all the students that we serve. So at the end of the quarter, I go and like take all this data and put it in some other hard swipe system so that we can like count all the students that we have seen during the quarter. So please, if you're coming either during class or after class, fill this out. And I will typically put it in the chat for the Zoom if you're coming during class, or if you're watching the video later, I'll usually have it linked right there. So great. As far as, yeah, and that actually, if you miss a class and you want to watch it later, you're welcome to do that. I post all the videos in Canvas and they're on YouTube and you can watch them. And then if you do watch them to make up for having not come to class, I would really appreciate it if you would also fill out the attendance form again for the same reasons. Let's see, what else have we got here? Yep, so unlike last quarter, no weekly reflections, no makeups or absences either. So you just got to come. And then the rest of the stuff is kind of like, so about this class, if something outside of class is impacting your success in math, please don't hesitate to talk with me about it. I would love to be a resource for you. I think I am. If something is said in class by anyone, including myself, that makes you uncomfortable, please talk with me about it. Or if it's me that's making you uncomfortable, which I don't anticipate at all, but you never know. And prefer to keep your feedback anonymous. You can use this feedback form or this other. My wife was like, has anyone ever done that? I'm like, I don't know. I don't think so. I was like, and she's like, what happens if you click on it? So let's see. If we click on this, it takes you to a place where you can leave a question or comment or provide feedback on the website. Okay, interesting. I'm curious now. It's for all of UC Davis. No, it's about AATC. Okay, so yeah, so you could totally leave feedback for anyone really if you wanted to that works with AATC, but that's just there in case you need it. As far as our class, again, we're meeting here. Class is going to be me showing you things, you asking questions, me having you work individually or together on stuff. Last quarter, something we started doing kind of like halfway through is people were writing questions on the board before class started. I thought that was really great. You're welcome to do that again. It's maybe a little more challenging to access the boards in this classroom. So even though I guess writing in front would probably be the best, I guess. But really pick whichever word you like. I just imagine the ones in the back aren't like, I don't want you all to have to like turn around to look at the problem, but the back would be fine as well. That one would also be fine, but seems like the hardest one to get to. So take your pick, whatever you like. I'll try to leave a couple pens. In fact, yeah, let me grab a couple pens. So we're here later. Up here. Up back here. So cool. Question that you want to. As you may have noticed for this class, homework is not due. That doesn't mean you shouldn't do it, as I'm sure you're aware, having taken at least 17B before this class. So we'll get to that a little bit more later. Let me just make sure I get through the rest of this here. Come to class prepared to work on math. You should have a writing utensil and something to write on. If there's something I can do to improve your ability to succeed, let me know. I've definitely gotten feedback over the years that has improved my teaching. I believe like One of the things that seemed really silly, but actually made a big difference was asking me to write with a thicker pen. So I used to write in a thinner pen and people just couldn't read what I was writing as well. So if you have something that seems like it might be easy or not, I'm open to your feedback now or later, whenever. If you have a formal accommodation through the Student Disability Center, please let me know as soon as possible so we can make sure you're getting what you need. This class doesn't really, I mean, I'm certainly happy to accommodate whatever needs there are, but also this class, there's not any exams or homework or really anything that require a strict accommodation. But if you need to record something, you're certainly welcome to, although I post everything anyway. If you need something else, either I'll get the letter or you can tell me, it's totally fine. Happy to accommodate whatever accommodations need to be made. I don't think we need to read the Zoom instructions. We've been doing Zoom for a while now. Some notes about the class. This class is worth 1 workload unit, meaning it's worth a unit towards being full-time, but not towards graduation, meaning counts for financial aid reasons. Oh yeah, yeah. Let me write myself a note here. A note or two here. Sure. Oh yeah. So I always write this, no one ever does it. You can use the discussion tab in Canvas to converse with each other as well as ask questions. I might try to use it a little bit more than I have in the past, and I'll show you what I mean in a little bit here. The rest of this, sure, the class, just like any math class you've taken, the material you learn is kind of related to the next material you learn. That's mostly true in this class, except for maybe like the last 2 weeks. The last 2 weeks of material is like, here's some totally new stuff that kind of feels very unrelated to anything else we've done in the class. So it's like the probability stuff at the end of the class. It'll be fine. You'll make it. Where can you get more help? Office hours, tutoring, which again, the drop-in tutoring starts next week in the library. I believe it's Monday through Thursday, 10 or 11 to 5, and then Sundays from 3 to 7, which you can find on our website as well if you go look. I think you usually can find it on our website, except right now, I believe it doesn't actually show the times. They'll say TBD. So they're probably figuring it out right now when they have tutors to work. Let's see. And then you should work with each other, get to know each other. You're a great resource for each other. That's definitely how I did it when I was a student, was studying with other students in the same class, asking each other questions, stuff like that. All right. Before we get more into the logistics of things or kind of the other half of the class, any questions on the syllabus? I think it's pretty straightforward. Again, if you're trying to get a unit for this class, you just have to come, make sure your name's on the attendance form. If I happen to forget the attendance form, remind me, and I'll pass around a piece of paper. You can write your names on it, and I'll go update the attendance in Canvas later on. And then I think these attendance assignments have due dates. You shouldn't worry about them. They're just on there for my own personal use. So don't worry about if you're not enrolled, don't worry about any grade you see in Canvas for anything. If you are enrolled, you should worry about the attendance grade you see. Cool, let's look at the modules, which is where you'll find anything useful in this class, which will definitely be the homepage very shortly. So right now, the homepage is the syllabus. I'll change that probably next week. Well, let me go to the student view here so you guys don't see all my secrets. There's a few things on there I don't want you to see just yet because you're not ready for it. All right, so at the top, we have useful links. So the attendance form, if you're not attending in person, you can find it there if I haven't texted it to you or chatted it to you. The link to the class Zoom, my office hours, again, we were just there. Probably the most useful resource, in my opinion, Grant's website over here. I will often steal lots of things from Grant's website. So if you look at these handouts and then you're like looking at the material from class, you might notice some overlap. That's totally okay. But definitely Grant has a lot of good, useful things here. Notes on all the topics, and I think he's got a final review down here, which is probably also on my Canvas page. Ooh, okay, let's go back to the modules. My website, which is not useful at all, just has my contact info on there essentially. Something I do think is useful is the syllabus from the department. So this is actually like what the department says you should be doing over like, how much time should be spent on each topic. So you've got like all of chapter 9 here, double integrals, which are not in the book. And we've got most of chapter 10, section 7, chapter 7, and then all of chapter 12. So, but then you can like look at each one and be like, okay, that's what we're doing. You can look at the textbook. So that's Not to say that your instructor couldn't deviate from that, right? Certainly people, Dell specifically, people sometimes do extra things in class or don't cover everything. So this is kind of what you should expect to see, but they might leave something out or they might add something in. But probably not. Lee's sticks to it pretty easily. Let's see what else. I keep going away from the modules here. Scrolling on down. Oh, I did also, I saw them. I posted the exam dates for Lee's class just so that you can see them easily if you forgot. Also, really more for myself because I'm always like, what day do you guys have a test on? And then I'm like, now you can just know it for me. Also, the playlist where you can see the old stuff I've done as well as the stuff I will upload. I will also post the class videos down below these links for graphing. There are some useful graphing links here. For now, these 3D ones, I would encourage you to play around with and get used to using. I think there's a couple things on this handout I'm going to give you that encourage you, have you kind of, actually, I don't have those. Those are actually, I think the things I have here are actually 2D graphing things, not 3D graphing things, but we'll see. It's a useful tool. Yeah, they are 2D graphing things, that's fine. So, and then also later on, we start talking about systems of linear differential equations. There's some useful graphing tools as well to kind of see how the thing looks. Lastly, there's some handouts, which I totally thought you all had access to over the weekend, but I forgot that it's not that it wasn't published, it's that I accidentally had like the start date for the course as January 8th. So no one could see anything. So that's not a huge deal. I've got copies of the handout that I'm going to hand out all to you. But my intent had been that you all could start early over the weekend. I know everyone was going to start right, I'm sure. So, but I didn't do it. So that's on me. And then lastly, if you're ever looking for a PDF of any of the chapters in your textbook, you can find them right there. Great. Questions? All right. I think that was one of so, oh yeah. So two more things. Discussions. So I did post, so instead of doing not instead of, since I'm not doing reflections this quarter, where so in the reflections, often people will be like, I would ask like, what should we work on next week? Or what do you want to see? People would write useful things. So I'm going to post discussions and then write things like, what do you want me to cover in class on Monday and Wednesday? And you can write whatever you want. And then also you're welcome to write stuff on the board as well. Yeah, that's kind of, and so I'll probably post, I think weekly is better than every class because it just seems like it'd be gross. We'll see how that works. Don't feel like you have to, but it would help me know kind of what you want to see. Also, but and then to that end, also, like I said before, homework is not due in your class, but you have, I think, weekly quizzes on like opening up a Tuesday and closing on Thursday. Which will probably be based very heavily on the homework problems that he is assigning you. So you definitely should do the homework problems. Like I should say it like 1,000 times. Pretend like I just said 1,000 times, do the homework. In fact, I don't think he's assigning enough homework personally. I don't think he ever assigns enough homework. But I also say he does, if you look at his Canvas here, let's go. Sorry, my cursor's all over the place here. Let's go home. I want to leave the student view, yeah. We go to his Canvas for 17C, which is right there. You can see the syllabus, sure, but if you look at the pages, that's where you can find the homework assignments. So there's week 1. Typically, he updates it as he goes. So this might not be the entirety of the problems from section 9.1. Often he will, when he kind of covers the material, he'll then add more problems from that section or from the next section. Yeah. I think that's about it. This instructor notoriously does not provide practice exams of any sort. So just FYI, I believe I have some of his older exams though from 17C, so I will write up some practice exams because I think that shouldn't be too difficult to manage. Yeah, I think I'm always like, there's another thing to say. I think that's everything. Oh, also he posts his lectures as well, right, in the media gallery, not the My Media. So I was watching that earlier today. And it's like, oh yeah, okay, you guys covered domain a little bit, and I feel like it was mostly and functions of two variables, right? He talked about functions. All right. Any questions about the logistics of things? Cool. It only took 20 minutes. That's not too bad. I feel like I'm like, can we just get through it, please, and talk about this? You got to say the words so that people know what's going on. I'm James. I'm James, by the way, just you didn't know my name. Please call me James. If you insist, you can call me teacher or Mr. Parmenter or professor, although I'm not one, but that's a common title people like to throw around. But really, you should just call me James because that's my name and I like it. But I understand not feeling comfortable with that sometimes. So it's totally fine if you call me something else. I'll hopefully learn your names. Maybe we'll see. There's few enough of you. I mean, some of your names I should know, and I definitely do not. So for those of you that were in class last quarter, I apologize. I probably don't know any of your names actually. I will try to learn them this quarter. Yeah. Okay. So functions of two variables, or I should say functions of several variables is actually the title, because technically you can have a function of more than two variables. But typically, we usually in this class talk about functions of two variables, sometimes three, but the ones that are functions of two variables are easier to kind of visualize. Thank you. Yes, that's another thing I should say. So if you ever can't see what I'm writing because either I haven't changed the screen, which often happens, or because I have pushed it up too high or something, just let me know. Also, if you feel like my writing is less legible than it could be, let me know as well. Oh, what's that? Is that just me? Oh, that's just me. There's like a little dot on the screen there. Okay, it's fine. Yeah. So let's see here. So functions of several, usually two variables. Let's think of a couple. So there's a couple examples that I was just running through my head. I was like, oh, what's some good examples of functions of two variables? One of them, it would be the volume of a cylinder, which looks like this. And it's got some radius and some height. If you think about it, the radius and the height completely determine the volume. So we can say that the volume as a function of radius and height is equal to, well, it's pi times r squared times h. Exactly a function of two variables, right? There's two different inputs, and depending on what they are, that completely determines the third output value. So for example, if the radius was 10 inches and the height was 12 inches, then the volume would be, I should say the volume evaluated at 10 comma 12 would be pi times 10 squared times 12, which would be 12 times 100 is 1200 pi cubic inches. Which is just an example of evaluating a function at a particular input. An interesting question here might be, what's the domain of this function? Well, this question I don't love because there's two technically valid answers. There's the answer of, well, if you look at this function, technically R could be anything, right? You could pick any value, positive or negative. Technically, right? It's not like a function that becomes undefined if I were to plug in a negative value for R. Same thing for H, right? Technically, the domain here, H, could be any positive or negative number. But that's not really the right answer. Because for something like this, we should consider the context of the problem. And here, the radius should be, in my opinion, I should say, not even non-negative, should be strictly positive, right? You shouldn't have a radius of 0 inches. That doesn't make sense for a cylinder. You shouldn't have a height of 0 inches. Your radius and your height should be strictly positive. So here, I would say the domain is the set of all R values and H values such that both R is positive and H is positive. And this is a typical way of writing domain, is that you're saying it's the set of all pairs, again, typically pairs if it's a function of two variables, because there's two different things that are being the input. And then what kind of the restriction on those inputs is. We'll talk more about this in a second. Often the way that people like us to kind of think about domain for functions of two variables is to graph the domain. So here we could, and again, this is kind of atypical because usually it's like with X and Y, not with R and H. But if, I mean, this is gonna be kind of funky because it's physically there. So I'm gonna draw my axes, but I'm gonna do something that I know I need to do. So I'm gonna make my axes dashed here. It's kind of weird, I know. So here's, I'm gonna think of R as being the horizontal, H as being the vertical, and I want R to be positive. So that means I have to be to the right and not include the origin. And I want H to be positive, which means I have to be up. So basically everything in this first quadrant, not including the axes, would be something in the domain. So the point, for example, 1, 1, or 2, 1, or 1, 7, right? Anything over here where R and H are both positive, totally in the domain. On the other hand, stuff out here, definitely not. R can't be negative, H can't be negative, and you can argue that R and H shouldn't be 0 as well. I had another example here that I wanted to get to. Sure. Yeah. Another example, which I think is in the textbook, is BMI, which stands for body mass index. And you can calculate a BMI, which again is just a made-up number, right? Someone decided that this number was a semi-decent description of whether someone is underweight, normal weight, overweight, obese, whatever. It's highly debatable. But the formula they came up with was that your body mass index with an input of your mass and your height, where your mass is measured in kilograms and your height is measured in meters, is equal to, what is it? Your mass divided by your height squared. Oh, this is the wrong size pen. Terrible. There we go. So again, this would be another example of a function that has the same kind of domain, right? Your mass shouldn't be 0. Your height shouldn't be 0 or negative, right? In fact, here you could probably even have like a lower bound, like 0 is probably too low, right? When people are born, usually the mass is, I mean, I feel like BMI for a newborn is probably not very sensible anyway. But here you probably have something like, I don't know, a domain of your mass being, let's say, greater than or equal to, let's say go with 1 kilogram, and your height being greater than or equal to, I have no idea how big newborns are. Let's go with 10 centimeters, which would be 0.1 meters. So that would be the domain, which again, I've written kind of an awkward way. The more typical way of writing, which again, I don't love, but is pretty standard, is we say our domain is the set containing all ordered pairs M comma H, such that M is bigger than or equal to 1 and H is bigger than or equal to 0. Graphically, that would look like, well, so typically, although not always, typically if you're having input written like this, the first one is like the X thing and the second one is like the Y thing. So I'm thinking of M being on my x-axis and H being on my y-axis. So I want M to be bigger than or equal to 1, and then I want H to be bigger than or equal to 0.1. So I'm thinking everything starting from here. So here's my domain that I'm shading in over here. Kind of funky. And then if you want to find the BMI of someone who was, say, I don't know, 70 kilograms and was 2 meters tall, because that's an easy number to plug in. It's pretty tall. 2 meters is right. It's more than 6 feet. Your BMI would be, let's see, 70 comma 2 would be 70 divided by 2 squared, which I think is 17.5. You could write units, but they'd be silly. They'd be kilograms per square meter. That seems like a weird unit to really write. So functions of 2 variables, not too terrible to start off with. We can evaluate them pretty easily just by plugging in numbers and getting outputs out. I think I had one more thing I wanted to say about this. All that. Okay, sure. Yeah. So where things get a little bit more interesting is more on domain. So while it's often going to be the case in this class, you're going to see functions of 2 variables that actually represent some real life physical thing like BMI or heat wave a wind chill or temperature humidity index or body surface area. There's lots of kind of interesting examples in the textbook here. Not every function is going to kind of be like that. You could have functions that aren't really describing a physical thing, that just kind of have issues we want to explore mathematically. So there's typically 3 things you have to concern yourself with when you have domain. So just kind of look back here for a second. If I look back at my original thing, so if I gave you a different function that looks very similar to the first function I gave you, I'm going to say this is f of xy is equal to pi times x squared times y. That function looks a lot like the surface area function I came up with earlier. But it didn't say it meant surface area. I just gave you a function. So great, there's a function. What's its domain? Well, are there any issues? That's what when I'm talking about domain, I was like, are there any domain issues? Is there any division by 0? Nope. Any square roots or any even roots, really? It's like a 4th root or a 6th root? Nope. Or any logarithms? No. There's one other thing you technically have to be worried about, which is an inverse trig function, but it almost never comes up. So I wouldn't worry about it really at all. So if you don't see any of those 3 kind of hallmarks for domain issues, then the domain is unrestricted. Now, that means different things in different contexts. Way back in 17a, if I had said that my function was, I don't know, 3x plus 1, you would have said the domain is, what is it? All real numbers, everything, right? The domain here is all real numbers, which you can write like this, or you can write it as this fancy R, or you can write it typically as everything from negative infinity to infinity. And the reason I stress that here is because that's not the answer over here. The domain here isn't all real numbers. I want to make that really clear again. The domain over here is not all real numbers. It's all ordered pairs of every combination of real number. So there's a couple ways you can write the domain here. So it's all points in the xy plane. That's one way of writing it. Or if you want to be super fancy, you can write it as R2. We don't say R squared, we really do say R2. But the most usual way you should write this, if you're asked to write it, is the set containing the points x comma y such that x is a real number and y is a real number. Or you could actually write the word x is real and y is real. So when you're talking about the domain of a function of 2 variables, you're not looking for numbers, you're looking for points. And if we drew this, it'd be kind of silly to draw it. You would literally just draw the xy plane and be like, okay, it's everything. So you'd be like, okay, everything, there's my domain. Which kind of feels silly. Draw, I should say. It gets more interesting when there's some domain restrictions. I thought I had, no, okay, sure. Okay, yeah, sure. Okay, cool. So let's look at what we've got here. I will also point out, although I'm not going to go about it. If this was just a a function that wasn't representative of physical quantities, then here we'd say, well, the domain was every ordered pair m comma h, except h couldn't be 0. But anything else would be fine. So we'd be missing the whole kind of y x axis here, where h was 0. Right? Everything here where h is equal to 0 would be not allowed, but everything else would be fine. So you scribble all this in and all that. Well, let's look at some more examples with the limited amount of time we have. It always feels like a rush on the first day because we're talking about the syllabus. So 3 examples here for domain. Let's say we had f of x comma y equal to, I don't love that example, the square root of x minus y squared plus 1. Which looks kind of funky. But whenever you're talking about domain, there's a really easy starting place depending on what type of thing you have. If you've got a square root or a 6th root of some stuff, as long as it's an even root, we know we have to have non-negative values underneath the root. Right? You can't take the square root of a negative number and get a real result. I will point out later on in this class, we will have imaginary eigenvalues popping up. So square roots of negative numbers are going to come back, but we don't really think about them when there's domain involved. So here we know, we'd say that, well, the inside stuff, x minus y squared plus 1, has to be greater than or equal to 0. And usually, you would try to rewrite this inequality in a way that made it easier to graph. Which would normally, not in this case, mean solving for y or isolating y. But here, it's actually easier and more sensible to isolate x. So I'm going to rethink of this as, oh, x is going to be bigger than or equal to y squared minus 1. Adding y squared and subtracting 1 from both sides. So I'm going to graph. So I should back up here a little bit. I'm kind of in my head about this because I've done so much. When people say domain, what they usually want is 2 things. 2 things. They want you to write the domain, which isn't particularly useful. I can write the domain right now. It's not going to tell you anything more than what I've already written. Here's the domain. It's the set containing all pairs of coordinates, x comma y, such that this inequality is true. It doesn't really help you know anything. At least anything more than we already know. The other thing people typically want, the more important thing, in my opinion, is to graph it. So the way we usually graph domain is we look at the inequality, and then we think about graphing just the equation if we replace this inequality symbol with an equal sign. So what we're going to do is we're going to graph x equal to y squared minus 1. Side note here. If this inequality is a greater than or equal to, so if you have actually, let me put my side, this is worth writing down. Side note. If your inequality is a less than or equal to or greater than or equal to, then you're going to want to graph the equation with a solid line. So graph using a solid line. Because that indicates that that boundary is included in the domain. On the other hand, if your inequality is a strictly less than or a strictly greater than, then you want to graph using a dashed line because we're not going to want to include the boundary. And that's how we indicate that. Whoops, can I spell dashed? Maybe. There we go. So here, since it's a greater than or equal to, I'm going to graph x equal to y squared minus 1 as a solid curve. I know that x equals y squared is a rightward opening parabola. Rightward opening parabola. Y squared minus 1 is going to shift it 1 to the left. So if that's a little bit much, the way you can think about it is just, well, if y is 0, x is negative 1. And if y is 1 or negative 1, 1 minus 1 is 0, 1 minus 1 is 0, x is going to be 0. So I get that point there, and that point there. And you can kind of start to see, oh yeah, there's the vertex of the parabola, and we're opening to the right. All right, so you're supposed to hit that point there. So there's that parabola. that is the boundary between what is included and what is not included in the domain. Which side do we pick? The easiest way to know this is to test a point that's not on the boundary. Test any point you like that you can clearly identify that is not in the that is not on the boundary. Pick something easy, like the origin, or the point 1, 0, or the point -2, 0. If I pick the point, if I pick 0, 0, so the question here is 0, 0 in the domain? Or in other words, does 0, 0 satisfy x bigger than or equal to y squared minus 1? Let's see, is 0 bigger than or equal to 0 squared minus 1? Yes or no? Definitely yes. 0 is bigger than or equal to -1. So since that point is in the domain, so is every other point that lives on the same side of the curve. So my domain is all of this. And none of this. And including the boundary as well. So for example, the point 0, 1 is a point that's in the domain. Because if you plug in 0 for x and 1 for y, you get the 6th root of 0 minus 1 plus 1, which is the 6th root of 0, which is 0. I should pause for a second here and say, if you have questions, you are always welcome to ask them. I know I sometimes talk a little fast. If you want to slow me down and ask a question, that's totally fine. I'm happy to say more things about a thing I've said. But also, if you feel like if everything's good, that's totally fine. I just want to make sure people feel comfortable.
Oh, so usually you want to separate the x and like the y when you have like a
I would say so, and more often you're usually isolating y, not x, because we're used to more frequently thinking of y as a function of x, not x as a function of y. But here that wouldn't have made a lot of sense. But yes, you're totally. I would agree with that statement totally. Let's look at a couple more examples before we run out of time. Yeah, we can get into 2 more examples. So, in addition to having square roots or even roots, another thing we have to worry about is if you have a function with a potential 0 in the denominator, like, I don't know, something, I don't love that example. Sure, let's say we have 6x plus 1 over x squared plus y squared minus 9. Yeah, it's a good example. So, in this case, if we're finding the domain, we know we want the denominator to not equal 0. There's lots of ways you could, you can do whatever you want. As an instructor, I typically write it this way. I want to exclude x squared plus y squared minus 9 equal to 0. That's the way I like to phrase it. I don't like to write not equal to 0 because it's just, I'm still going to try and solve this equation in a way that makes more sense to me. So I don't want all these points. Well, typically when you see an x squared plus y squared, it's a really, really good clue that you probably have a circle somewhere. I would probably re-express this as I'm going to exclude x squared plus y squared equal to 9, which is a circle of radius 3. Centered at the origin. So here's how we're going to write the domain. It's the set of every x and y pair that isn't on the circle. So that x squared plus y squared is not equal to 9. I would use a not equal to symbol there. Any other point's fine. It just can't be on the circle of radius 3. And then drawing that's going to look kind of weird. So I'm going to draw the circle of radius 3, but I don't want to include it, so I'm going to use a dashed line, or dashed curve, I should say. So here's my stuff not included in the domain. And then everything else is good to go. So all of this and everything outside of the circle as well. There's my domain. Every point except for any point that's on the circle. So the point 3, 0 is out. The point 0, 3 is out. The point square root of 4 and square root of 5 is out. Right. All those points that would get you on that circle are totally not good. Everything else is totally fine. So, two types of domains so far. We can't take a square root of a negative number, so all the insides have to be non-negative. We can't divide by 0. And then the third issue that comes up is logarithms. So for example, we might have something, I'm gonna do something kind of similar here. F of x comma y equal to the log base, let's go log base 2 of 16 minus x squared minus y squared. Which, let me ask you all, based on what I've written inside the logarithm there, what kind of shape do you think might show up? A circle again, right? If you actually, so if you have an x squared plus y squared or a minus parentheses x squared plus y squared, if that's showing up in either way, good bet circles going to show up. Not, I want to say all the time, there's probably a way you can make it not happen, but it's pretty likely. So here, we're going to start off by saying, well, the domain, well, for logarithms, I think of logarithms and even roots very similarly in that they have a similar domain restriction. Not quite the same. For square roots and 6 roots and even roots, the insides have to be greater than or equal to 0. Right? You can take the square root of 0. You can take the 6 root of 0. Right? Square root of 0 is 0. 7th root of 0. 8th root of 0 is 0. 7th root is also 0. But odd roots, I should point out, odd roots are totally safe. If someone gives you, real quickly on the side here, if someone gave you this function, g of xy equal to the 7th root of 9 minus x squared plus y to the 3rd, you shouldn't have to think at all about the domain. The domain here is not all real numbers, all points in the xy plane. So the domain here is everything you can get, which is all xy such that x and y are real. Because you can take the 7th root of any positive or any negative number. Back to this though. Here, for logarithmic functions, the argument or the insides have to be strictly greater than 0. You can't take a log of 0. You can't take the log of a negative number. Because you're saying 2 to some power would be equal to that 0 or that negative number, and there's no such real number that exists. 2 to the anything is always positive. So it can't be 0, it can't be negative. Here, I'm going to do the same sort of thing I did up here and isolate the x squared plus y squared. I would prefer them to be positive. So instead of subtracting 16 over there and then multiplying by negative, I would just add x squared and y squared to the other side. Or I would probably prefer to write it as x squared plus y squared less than 16. And I know that if I were to graph x squared plus y squared equal to 16, that's going to be the circle sent into the origin of radius 4. But since I know that I have a strictly less than or strictly greater than inequality here, I want to graph it dashed because I don't want to include that boundary, whichever side of it I happen to be on. We draw a little dashed circle here, radius 4. And then, same kind of deal as before, we pick a point and see if it meets the criteria or not. So I'm going to pick a point that I know doesn't. I'm going to pick the point 5, 0, which is on the outside of the circle here. If I test it, well, 5 squared plus 0 squared, is it less than 16? Definitely not. Right? 5 squared is 25. That's bigger than 16. So no. That means this point is not in the domain. It means all the points on this side of the circle are not in the domain. It means the other side of the boundary is our domain. And that's a valid way of testing. So if you just have one boundary separating the domain from the not domain, test a point on either side, and if it works, it's all those. If it doesn't work, it's all the other ones. If you have more boundaries, like there was an example of that in class, it's a little bit more work to kind of figure out what it is, but we can talk about that on Wednesday since we're out of time today. Cool. Make sure you sign the sheet if you didn't already. I think you all did, but if you didn't, make sure you did. And I'll see you on Wednesday.